So now let us go on to part C. I need a new color for this because now we're going to look at probabilities that are actually conditioned. So C. We want to look at the probability that a 20-year-old will survive age 40. So the probability that a 20-year-old survives age 40. And what does that mean? So if you're 20, so if this is your age, and you want to survive age 40, that means you're 20 and you want to survive the next 20 years. So i.e. survives the next 20 years. So note that we're kind of, in a way, nurturing our intuitive understanding of lifetime and becoming more sophisticated at differentiating between different ways we look at lifetime and lifespans. Because what we're doing here now is noticing the fact that the probability that a 20-year-old will survive age 40 is probably not the same as the probability that a newborn will survive age 40. And how come? Well, in some countries, for example, third world countries, you might have a significantly better chance of surviving age 40 given that you're past the first most dangerous 5 years of your life, where, children can die of loads of stuff that maybe adults are more resistant to. So that probability that you can survive age 40, for example, that probability will change with age. So given that you're able to survive until 20, that's maybe a sign that you're resilient enough to survive age 40. Whereas when you're a newborn, probably you're not yet among those that have proven themselves resilient enough to survive age 40. Another thing is, sometimes we ask the question, what's the probability that I will survive the next 20 years? So what's the probability I will survive the next 20 years? Now that kind of depends, right? If you ask an actuary, the actuary will tell you that depends. Are you 100 years old or are you 20? If you're 20, then the probability you'll survive the next 20 years is probably quite good, because that means you're 20 years old, and we want to consider the probability that you survive age 40. However, if you are 100 years old and you ask, well, what's the probability I survive the next 20 years? Then the actuary will probably say, well, look, nutrition has gone way up and people are living as long as ever, but your chances of surviving the next 20 years are probably a bit worse now that you're 100 compared to how they were when you were 20, because it's just harder to go from 100 to 120 than it is to go from 20 to 40. But it might depend, it might depend. Nothing is set in stone, and maybe just the fact that you can survive until 100 proves that your resilience is such that it's also very probable you will survive until 120. But the important thing is that mentally we're able to differentiate. So all of that was just me talking without any text or anything. So let me just write this down. We differentiate between the probability that a newborn can survive past age 40, given the newborn is newborn, so given we only know that the person has survived past 0, so this is the different from the probability that the person can survive age 40, given that the person has survived age 20. So these two are not equal to each other, just in the sense that the probability that a person can live 20 years longer, given the person is 20 years old. So the probability that the person can go until age 20 plus 20, well, that is also different from the probability that the person is 100 years old, or that the person survives age 100 and and wishes to go beyond age 120. So there are some subtle effects here, which also means that the question, what is the probability of living another 20 years? Well, the answer to that question is, first and foremost, it depends on your age at the present. So this was just, I'm going to just box this into this red thing here. Just a little intuition box for you guys. Just so you kind of understand, well, there is a reason why we talk about these conditional probabilities. It's not just something where we thought, well, that could be nice to look at. It's actually relevant. So there is also a notation that we use for this, just because that it often gets very tedious to keep writing up these conditional probabilities. And the notation that we use is this. So the probability that t is greater than some t plus x, given that t is greater than x. So this is normally what we say, that this is what we call the probability that an x-year-old survives the next 10 years. Not 10 years, sorry, the next 2 years. We denote this also by the probability that the remaining lifetime of an x-year-old is greater than t. So this is what we call the remaining lifetime of an x-year-old. And we also denote this using this symbol here. So the probability that an x-year-old survives, where p stands for survives, the next t years. So there is a lot of different kind of notation in play here. But all in all, no matter which kind of notation we use, then we know that the probability that a 20-year-old survives age 40 is given by, well, the probability that a 20-year-old survives age 40, so survives the next 20 years, is given by this formula over here. It's given by the probability that a newborn survives past age 40 divided by the probability that a newborn survives past age 20. Where I use this formula, I see that x plus t, 20 plus 20 is 40, so that's what goes up here. And the x, which is the age of the person at the moment, is 20, so that goes down here. And what is the result of this? Well, the result of this is 1 minus 40 over 110 divided by 1 minus 20 over 110, and to the what power? To the 3/4, is equal to 0.8282, hopefully. And that is the answer to C, the probability that a 20-year-old will survive past age 20. Not age 20, age 40, so will survive the next 20 years. So for the last part with the mortality intensity, we'll go to the next video. So just click next.